Hi guys! Today we're going to do something a little bit different. I've actually recorded on this video some of the notes on section 2.5 polynomials. So I'm expecting that you'll take the notes at home that I put in this video, and then tomorrow we can discuss these notes and work through some problems involving polynomial functions. Okay, so again, the section is going to be on polynomial functions, which we started today in class. Okay, so the word polynomial actually comes from two different words. The first part, poly, comes from a Greek word meaning many. So poly you can think of as many. And nomial comes from a Latin word meaning name or, for us, terms. And you'll have to excuse my writing on this iPad because I'm pretty new at it, so it's going to be terrible. So there are going to be two different ways that we name or classify polynomials. So two ways to name or classify polynomials, and we've used some of these names before. The first way is to name a polynomial by its degree. And I've actually defined degree on the next slide. It's the highest exponent. So the first way is to name it by its degree. And the second way to name a polynomial is by the number of terms it has. This we haven't really done, although I might have mentioned one or two in class. So we have named them by its degree before, you'll see on the next slide, but we have not named it by the number of terms it has. Okay, and at any point, if you are not able to take notes as fast as I'm talking, you can always pause the video to finish taking these notes. But everything you see on the screen right now is something that I would like you to have in your notes tomorrow. So on the next slide, I have all the different ways we can name polynomials by their degrees. So let's look at that now. Okay, and here you can see I've named degree is the highest exponent of a polynomial. So let's actually start with one that we know, linear. We'll go back to constant in a second. Okay, but a linear function, and let's see if the green marker shows up, it does. A linear function, its highest degree is 1. So for example, I could put y equals, 5x minus 3. But the highest exponent comes from the variable term, which would be x, and in this case, that exponent is a 1. So the degree of this is 1, and that's known as linear. So anytime we have something like this, as we would know well, we call it linear, but we're really naming it by its degree, which is 1. Okay. Quadratic, we've covered that one as well. So that highest degree, highest exponent, would be a 2. For example, negative 4x squared. So there, the degree, my writing is terrible here, is 2. Okay? We have also talked about cubic a few times, and so the degree or highest exponent for a cubic would be 3. So for example, let's see, 7x cubed minus 12x, that could be an example. Let's put a third term in there, plus 3. So that has a degree of 3. And a quartic would have a degree of 4, and a quintic would have a degree of 5. And that's actually as high as we're going to go for this class. And that's actually as high as most people go. After that, you would just say a polynomial with degree 6 or degree 7. But you'll notice here that I've left some room, and I'd like you to fill in two examples, one for a quartic and one for a quintic that we can go over tomorrow in class. So you may want to pause the video at this point to fill in your remaining quartic and quintic, or if you haven't finished the notes that I wrote here, but I'm going to move on to the next slide. So maybe you want to pause the video now. All right. So on the third slide, we're going to discuss the second way you can name polynomials. And that second way is to name it by the number of terms it has. Okay? So If you have one term, then that would be known as a monomial. Mono means, oops, I just spelled it wrong. Mono, with an N, means one. So let me erase that there. So there's my N. Monomial. Sorry, guys. So that's the first name. And an example of that could be just something as simple as y equals x squared. It has one term, so it's a monomial. If you have two terms, well, this should start to make sense, and I think I've used this before. You have a binomial. Bi, like bicycle, has two wheels. A binomial would have two terms. So for example, y equals 7x to the fourth, which would also be a quartic, minus 6. So this actually would be a quartic binomial if we were to use both names at once. And finally, we actually only go up to 3 terms with this, with our names. And so if you think of a bicycle with 3 wheels, it's actually not called a bicycle, it's called a tricycle. And so our 3 terms will not be a tricycle, but a trinomial. So a trinomial will have 3 terms. For example, we could put y equals, let's see, 7x to the 5th, I guess I like the number 7 today, minus 2x plus 1. So this would actually be a quintic, because it's to the 5th power, trinomial. So on the final slide, I'm going to put 4 examples, and I'd like you to name each of those, and tomorrow in class we can go over the names for these 4 examples. Okay, so that's on the next slide. Okay, so here are the 4 examples, and you should name each one of them, and again, we'll go over them in class tomorrow. And for the fifth problem, I'd like you to give me an example. For a quadratic binomial. Any example of a quadratic binomial. There's an infinite number of possibilities. Thanks for listening to the video. It was my first try, so obviously there's room for improvement, but I hope it was helpful.